Hello, today we are doing class 10 physics second chapter work, energy and power, and in this video we learn about the different forms of energy. So energy, what is energy? Energy, energy. So when we do small work we require energy, like I'm speaking, I need energy to speak. In order to move my hand also I require energy. So to do small work also we require energy. So we can say that energy is the ability to do work or capacity to do work. Energy is defined as the ability to do work or it is a capacity to do work. There are many forms of energy: radiant energy, electrical energy, thermal energy, electromagnetic energy, chemical energy, nuclear energy, mechanical energy. Okay, and today we will do different forms of mechanical energy. Energy possessed by a body when at rest or in motion is called mechanical energy. It's rest or motion. Energy possessed by a body due to its rest or its motion is called mechanical energy, and this is divided into two groups. One is your potential energy and the other one is your kinetic energy. Okay, and potential energy we'll write symbol U, capital U, or simply PE, and kinetic energy is your KE, or sometimes we also will write this way. Okay, this is your kinetic energy, and the formula for the potential energy is your mgh, and for kinetic energy is your half mv square. Okay, so energy possessed by a body when at rest is your potential energy, and energy possessed by a body when in motion is your kinetic energy. So sum of potential and the kinetic energy will give us mechanical energy. First we'll do potential energy. So potential energy, and this is we write PE. The formula is here mgh. M stands for mass, g is here acceleration due to gravity, and h is the height. Okay, so what is potential energy? Energy possessed by a body at rest due to its position or simply shape and size is called potential energy. So potential energy, that means energy possessed by a body at rest due to its position or shape and size is called potential energy. Okay, and this potential energy is divided into two forms here: gravitational potential energy, and the other one is your elastic potential energy. So first we learn gravitational potential energy. So every object are attracted towards the earth due to the force of gravity or due to its weight, and we know that weight is the force of gravity only. How do you define weight? Weight is the force with which the body is pulled towards the earth due to the force of gravity. The potential energy possessed by a body due to the force of gravity is called gravitational potential energy. So let's take one example. If we have a body of mass m which is kept at a height h from the ground or earth, if the body is kept at height h above the ground, above the earth, does this body do any work? Do this body has any kind of energy? Let's find out. So if we let this body to fall freely under the force of gravity, then below this body we will have particles, dust particles, air particles, okay, and when the body will fall freely, it will force this particle to move downwards. All these particles will move downwards due to the force. This body will, or these particles will experience some force. It is moving all these particles downwards. It also experiences displacement, and we know that product of force into displacement is simply work. That means this body is doing some work. If this body is doing work, means due to its position, the body has some energy. Okay, the energy possessed by a body due to position is your potential energy, and this kind of energy is called gravitational potential energy. The potential energy possessed by a body due to the force of gravity is called gravitational potential energy. Gravitational potential energy increases with height, but if we take this to infinity, then the gravitational potential energy will be zero. Also, when the body is on the earth's surface, at that time also gravitational potential energy will be zero. And next is your elastic potential energy. When an external force is applied on a body which will deform its shape and size, and the potential energy possessed by a body to deform its shape and size is called the elastic potential energy. Let's take one example. If you have a coil here or spring here, and if we apply here external force, when we apply external force, the coil will be deforming its shape and size. So the coil was like this. Now because of the external force, the shape and size of this coil is deformed. So when the shape and the size of the body is changes, then the energy possessed by a body is the potential energy, and that potential energy which made the body to change its shape and the size is called elastic potential energy. Let's derive the formula for potential energy. If we have a body of mass m initially at the ground with height is equals to 0, initial height is 0, and the body is moved upwards, okay, or lifted upwards, and the body will reach at height h. Okay, this is your final height. When the body is lifted, upward, force required to lift the body is equals to weight of that body. Force required to lift the body is the weight of that body. Weight is nothing, weight is a force, and we know that force is equals to mass into acceleration. Here mass is your m body, and acceleration is your mass into acceleration is your acceleration due to gravity. So mass is your m, acceleration due to gravity is your z, so your force will be mg. And similarly, when the body is lifted from initial position to the final position, there will have some displacement on the body. Displacement is the shortest distance between the initial and the final position of the moving body. That means final position minus initial position. Okay, and finally the body is lifted to height h. Final position is h. Initially the position of the body was on the ground, wherein height is 0. 0 is equals to h. From these two relations we can get, first we know work is equals to force into displacement. So work is what? Work done means some energy. Energy due to its position is a potential energy. So our potential energy is equals to force. Force is here mg and the displacement is here h. So this is how we will get potential energy is equals to mg h. If the body is thrown vertically upward, what happens? We'll see that when the body is thrown vertically upwards, the height of the body increases. When the height increases, your potential energy will also increase. Okay. Similarly, when the height of the body is decreases, the potential energy will also be decreased. When the height decreases, potential energy of the body will also be decreased. And when the body reaches to the earth's surface, potential energy will be zero. On the earth's surface, potential energy will be zero. On earth's surface, H will be zero, then potential energy is equal to mgh is equal to mgh is here 0. 0 multiplied to anything is 0. So that means on earth's surface, potential energy will be 0. From here we understood that when the height increases, potential energy increases. When the height decreases, potential energy decreases. If you have to find the change in potential energy, if the body is moved from height h1 to height h2, here the height is increasing. If h1 is less than h2 or h2 is greater than h1, for this potential energy will be a mg h1 and here is a mg h2. So increase in potential energy or gain in potential energy will be a final potential energy minus initial potential energy. This is your final and this is your initial potential energy. So final potential energy is mg h2 and the initial potential energy is mg h1. Gain in potential energy, if we take mg common, is h2 minus h1. Clear? This is your gain in potential energy. But if we have the body at height h1 and if we are taking this body to height h2, h1 is greater than h2. Here the body is coming towards the earth. When the body is coming towards the earth, when the height will decrease, potential energy will also be decreased. So decrease in potential energy or loss in potential energy will be initial potential energy minus final potential energy. This will be here mg, this is here h1 minus mg h2, this is equal to mg h1 minus h2. Let's take one example. If you have a body of mass m1 is equals to 1 kg and another body of mass m2 is equals to say 5 kg, and both the bodies are allowed to fall from the same height. So h is equals to say 10 meter, and if two bodies are falling from the same height h, here also h, here also h. Now if you have to calculate the potential energy of these two freely falling body, so here potential energy, so this is body A, this is here body B. So potential energy of A is equals to mg h is equals to mass is here how much? m1. gh is here 1 into acceleration due to gravity, g is equals to approximately 10 meter per second square. This is here 10 meter per second square. This is here 1 kg into height is here 10 meter. This will give you 10 into 10, 100 into 1, 100 kg meter per second square is here Newton meter. This is a 100 joule. So the body, the potential energy of the body A will be 100 joule. So that means it will does 100 joules of work. Here potential energy of B will be how much? mgh. M2 is here 5 kg into 10 meter per second square into 10 meter. This is here 5 10 are 50 50 10 are 500 kg meter per second square is a Newton meter is equals to 500 joule. So from here it is clear that when the mass of the body increases, the potential energy will also be increased. More the mass, more is the potential energy. Two bodies of same mass, mass is equals to 1 kg, okay, is falling from a height say 10 meter, and another body of same mass is equals to 1 kg is falling from a height say 15 meter. So now we have to calculate the potential energy here. So potential, suppose A and B, potential energy of A here is how much? mgh. M is your mass is your 1 kg, g is your 10 meter per second square, and height is your 10 meter. This will be 100 joules. Okay, here if you calculate, this is your PE, potential energy of B is equals to mgh, mass is your 1 kg into 10 meter per second square into 15 meter here. 15 10 are 150. Okay, 15 10 are 150, that is 150 joules of work. So from here also we can say that this potential energy of B is more than the potential energy of A. The height of B is more than the height of object A. More is the height, more is the potential energy. Similarly, more is the mass, more is the potential energy. So we can say that potential energy depends on two factors. One is the mass of the body and other is the height. Okay, these are the two factors on which potential energy depends, and potential energy is proportional to mass and height. If mass increases, potential energy will increase. If mass decreases, potential energy will decrease. And when height increases, potential energy will increase. When height decreases, potential energy will also decrease. Also we know that at infinity, if the height of the object is infinity, your potential energy is zero. Because gravitational potential energy will be zero there. Gravitation will be zero. So that means if the zero gravity, potential energy is zero. And on Earth surface, H is equals to 0, therefore potential energy is equals to 0. So there are two cases when the potential energy is 0. When the body is on the Earth's surface, then the potential energy is 0, or when the body is at infinity, potential energy is 0. Clear? Next is your kinetic energy. So what is kinetic energy? Energy possessed by a body due to its motion. Okay, due to its motion is called kinetic energy, and kinetic energy is written as Ke, and its formula is half mv square. Okay, energy possessed by a body due to its motion is called kinetic energy. So kinetic energy have different forms. One is here translational kinetic energy. Translational kinetic energy. Translational means straight line. When a body is moving in a straight line path, then the motion of the body is called translational motion. Kinetic energy possessed by a body in a translational motion is called translational kinetic energy. A car moving in a straight line path, car is moving in a straight line path. Kinetic energy possessed by a car while moving in a translational motion is called translational kinetic energy. The body is falling vertically downwards. Here you can see the motion of the body is translational. Kinetic energy possessed by a body, freely falling body in a translational motion is called translational kinetic energy. And number 2 is your rotational kinetic energy. So what is rotation? To rotate about its axis. Suppose if you have a fan and when we switch on the fan will start rotating about its axis. So when the fan is rotating about its axis, the kinetic energy possessed by a rotational motion of the fan is the rotational kinetic energy. When the car is running, the wheel of the car is rotating about its axis, then the kinetic energy possessed by a wheel of the car in a rotational motion is called rotational kinetic energy. Okay, and third one is your vibrational kinetic energy. So vibrational kinetic energy, suppose we have two rigid support and if we tie a rubber band and if we stretch from its center, the rubber band will start vibrating to and fro. When the body will vibrate to and fro. So kinetic energy possessed by a body in a vibrational motion is called vibrational kinetic energy. If we pluck the string of the guitar, the string will start vibrating to and fro. That is also the example of vibrational kinetic energy. Let's derive the equation for kinetic energy or the formula for kinetic energy, which is half mv square. We know that kinetic energy is your retarding force into displacement. We can say that the kinetic energy possessed by a moving body is equals to the work done by the moving body before it comes to rest. It is retarding force. So let's take one example. If we have a body which is already moving with a certain velocity. So initially here velocity is v, moving with a initial velocity. U is your initial velocity. Due to some opposing force, the body will stop after traveling s distance. So body will stop here or body will come to rest. So at that time final velocity v will be 0 here. Now, so if you have to find the retarding force here, retarding force is what? What is force? Force is your mass into acceleration. Here mass is your m, mass into acceleration is your retardation. So this will be a mass m, retardation is a. So force is equals to m, a for displacement. Displacement is here initial velocity u is equals to v and final velocity v is equals to 0. And since the body is retarding here, acceleration a is your minus a. We know from the equation of motion v square is equals to u square plus 2as, or v final velocity is how much? 0 is equals to u square is your u, initial velocity is your v square plus A is here minus A, that's why this side will become minus 2AS. Or if you write here 2AS is equals to V square, or S is equals to V square upon 2A. If you take this as equation 1 and this as equation 2, we know work done is equals to force into displacement. MA is the force into displacement, here is V square upon 2A. So if you have A cancelled, so we will get here half mv square, and work done here is your kinetic energy. So this is how we can derive the formula for the kinetic energy. The kinetic energy depends upon two factors. One is the mass and another is the square of the velocity. We got here kinetic energy is equals to half mv square. So what will happen if we halve the velocity of the body? If the velocity of the body is half, then what will happen to the kinetic energy? So at that time kinetic energy will become half into m into half, 1 by 2 square. This will be 1 by 2 m into 1 by 4. Here the kinetic energy will decrease by 1/4. When the velocity of the body is half, the kinetic energy will decrease by 1/4. If you make the kinetic energy 1/3, the velocity of the body will decrease by 1 by 9 times, because the kinetic energy of the body depends upon the square of the velocity of motion of the body. If we make the velocity double 2 times, so what will happen to the kinetic energy? Kinetic energy will become half m into 2 square is equals to 1 by 2 m into 4. So the velocity of the body will increases by 4 times. If we make the kinetic energy triple 3 times, then the velocity of the body will increase by 9 times. Kinetic energy depends on mass and velocity. So these are the two factors on which kinetic energy depends. Okay, so between kinetic energy and momentum. So we know that kinetic energy is equals to half mv square. Let's take this as equation 1, and momentum is denoted by small p is equals to mv, motion of the body. Let's take this as equation 2. Squaring equation 2 on both sides, we get p square is equals to m square v square, or p square divided by m square is equals to v square. This is a equation 3. So if you compare equation, or if you put the value of v square on equation 1, we get, okay, putting the value or substituting the value of v square in equation 1, we get, so kinetic energy will become 1 by 2 m v square is here p square divided by m square. So from here 1 m will get cancelled, so kinetic energy will become p square divided by 2 m. So this is the relation between kinetic energy and the momentum. Okay, or we can also write here, so p square is equals to 2m into kinetic energy, therefore p is equals to 2m into kinetic energy root under. Okay, this is another relation for the kinetic energy and the momentum. This is by rooting here. Okay, if we remove the square, if the momentum of the body is given 10 kg meter per second, and mass of the body is here 5 kg. Then here kinetic energy will be here P square upon 2m. Here P is here 10 square 100, 10 into 10 is here 100 kg square meter square per second square whole divided by 2 into m is a mass 5 kg. So this will cancel, 5 it will go 20 times and 2 it will go 10 times. So this will become here 10, this kg will go cancel, kg meter per second square into meter. We can write like this way. So we know that kg meter per second square is a Newton, meter is a 10 joule. So the SI unit, so here SI unit of kinetic energy is also joule or denoted as J here. So in other way also we can find the kinetic energy. Kinetic energy is equals to half mv square. V is a velocity. So we know that momentum is equals to mv. Momentum is equals to mv, or here momentum is given here 10 kg meter per second and mass is given 5 kg and velocity is v, and if you cancel kg, 5 will cancel 10 2 times, therefore v is equals to 2 meter per second. Half m is your mass 5 kg and the velocity is your 2 square, that means 4 meter square into second square. This is your 2 1 times 2 times, this will become 5 to 10 kg meter per second square into meter, meter per second square into meter. This will give you 10 joule. Okay, either way we can find the kinetic energy. Suppose if the kinetic energy is a 10 joule, okay, and the mass of the body is equals to how much? 5 kg. So how we can find the momentum? We know that momentum is equals to root under 2 into m into kinetic energy. It's here 2 into m is here mass 5 kg into kinetic energy is here 10 joule here. Okay, and 10 joule is nothing, this is a kg meter square second square per second square. Okay, and from here we will get here 5 to 10, 10, 10, 10 are 100 kg square meter square second square root under, if you remove this, this will become 10 kg meter per second. This is how we can find the momentum as well as kinetic energy with the help of the relation between the kinetic energy and the momentum. So let's take one example. If you have body A with mass m and if you have body B with mass m, and here m is greater than m and both the bodies have same momentum, P is same. We have to find that which body will have the more kinetic energy. So kinetic energy for A, body A is equals to P square upon 2 body A, mass is here m, and for kinetic energy of body B will be how much? P square upon 2 m. Dividing this we will get KE A divided by KE B will be how much? This is a P square divided by 2m whole divided by P square divided by 2 capital M. This can be written as P square divided by 2m into reciprocal 2m divided by P square. This will get cancelled, 2 will get cancelled, therefore we will get here KEA by KEB is equals to m by small m. Okay, since m is greater than m, therefore kinetic energy of A will be greater than kinetic energy of B. We can see that when the two bodies of different mass and has the same momentum, so the body with the lesser mass will have more kinetic energy to that of the body with the more mass. Again, we'll take that a body A has mass m and the body B has mass m. So m is greater than m and both the bodies have same kinetic energy. So what will be the relation of the momentum between these two bodies, or the whose momentum will be more? Let's find out. This is a lighter body, this is a heavier. Okay, so we know that here momentum is equals to how much? Root under 2m into kinetic energy. Here momentum of A is equals to this, and momentum of B is equals to root under 2 capital M K E, kinetic energy, because both the body has same kinetic energy. So dividing these two, we get momentum of A divided by momentum of B will give you 2m Ke divided by 2 capital M Ke. So both are under root, so this can be written as together 2m Ke divided by 2m Ke. So potential kinetic energy cancel, 2 will get cancelled, remaining will be root under m divided by root under capital M. Since m is greater than m, therefore momentum of B will be greater than momentum of A. So from here we got to know that if the two bodies of different mass has same kinetic energy, then the momentum of the heavier body will be greater than that of the momentum of the lighter body. Okay, this is a work energy theorem. So we know that what is work? Work is equal to force into displacement into cos theta, and here energy we are talking about the kinetic energy. Work done is equals to change in kinetic energy. So change in kinetic energy is nothing. This is a final kinetic energy minus initial kinetic energy. Half m final V and initial is a half m u square. Initial velocity, okay, is a u is the initial velocity, v is the final velocity. This will give you half m v square minus u square. This is the change in kinetic energy. So work energy theorem is nothing. It is a work done is equals to change in kinetic energy. According to the work energy theorem, the work done by a moving body in the direction of the force is equals to the increase in kinetic energy. Let's take one example. If the body is moving with initial velocity u is equals to 10 meter per second and the force is applied in the direction of the motion, then the velocity of the body increases. Final velocity will become 10 meter per second and the mass of the body is m. Okay, so if the question will come, find the work done. So work done is equals to force into displacement into cos theta. Here the force is not given, here the displacement is not given, but we have to find the work. But with the help of work energy theorem, we can find the work here. Okay, this is the beauty of the work energy theorem. How do we find here? So work done is equals to change in kinetic energy. change in kinetic energy, final kinetic energy minus initial kinetic energy, okay, which will be half m v square minus u square is equals to half m. V is how much here? V is here, suppose this is a 30, increases to 30, so this will be a 30 square minus m is here, sorry, u is here 10 square, this is a meter square per second square, this is here, okay. Suppose the mass of the body is 1 kg, so here the mass is here 1 kg, so this will become 1 by 2 into 900 minus 100 kg meter is per second square into meter is here joule is equals to 1 by 2 into 800 joule is here 400 is equals to 400 joule. Here work done by the body is 400 joule and here the work done is positive. Okay, since the force and the displacement is along the same direction, when the force and the displacement is along the same direction, work done will be F into S into cos theta. Here angle between the force and the displacement is 0. When the theta is 0, okay, the cos 0 degree is equals to 1. 1 into any number will get the same value. So here the work done is positive. Let's take another example. If the ball is falling downwards, the ball is displacing this direction. In order to stop the ball, we have to apply the force upward here. The ball pushes the body downward. So that means displacement will be towards downward direction and the force we applied will be in towards the upward direction. Initial kinetic energy is here half m u square, okay, initial, and the final will be here this one half m v square. Change in kinetic energy will be here final kinetic energy minus initial kinetic energy. The ball is coming to rest. Finally the ball will come to rest. The velocity will be 0. Entire this will be 0. It will be minus half mu square. Regardless of any value of m and the u, change in kinetic energy will be negative. Okay, or else here we can see from the definition work is equals to force into displacement into cos theta. The force is applying in the upward direction and the displacement will be in the downward direction. Angle between the force and the displacement will be 180 degree and we know that cos 180 degree is equals to minus 1. Regardless of any value of force and the displacement, work done will be here negative. According to the work energy theorem, whatever work we do, whether it is positive or negative, will result change in kinetic energy. Let's do the proving part or else you will not believe this. We know change in kinetic energy is equals to final kinetic energy minus initial kinetic energy. Final kinetic energy is here half m v square and initial is here half m u square. So let's take only m common. If you take m common, this will be here v square minus u square divided by 2. This is equals to, we can write m a into v square minus u square divided by 2a. Here we multiply by a by a. If we cancel this a and this a, we are going to get the same form. Okay, it will not change because we have multiplied both numerator and the denominator with the same number. So here ma is a mass into acceleration, and mass into acceleration is what? Mass into acceleration is what? It's your force. Force is equals to mass into acceleration. So ma will give you force, and here from equation of motion, what we get here? V square is equals to u square plus 2as or v square minus u square is equals to 2as or v square minus u square divided by 2a is equals to s. S is the displacement. Okay, so v square minus u square divided by 2a is your s. And we know that force into displacement is your work done. So we have proved this. Work done is nothing, it is a change in kinetic energy. And this is your work energy theorem. Okay.